When studying probability, you might have been taught that the probabilities of mutually exclusive events sum to 1. However, this is wrong. This is Mr. Butler Maths, and in this video, we are looking at the definition of mutually exclusive and explaining a mistake that even some maths teachers make. Let's start by defining what we mean by mutually exclusive. Events are mutually exclusive if they cannot happen at the same time. For example, as there's only one of me, I cannot physically be in both London and Sydney at the same time tomorrow morning. Therefore, these events are mutually exclusive. As an example of some events that are not mutually exclusive, let's think about a die. Rolling an even number on a die and rolling a 2 on a die are not mutually exclusive because these events can happen at the same time. 2 is an even number, so if I roll a 2, I have both rolled an even number and rolled a 2. Therefore, as we said, these events are not mutually exclusive. Now we know what mutually exclusive means, let's look at why the statement, the sum of the probabilities of mutually exclusive events sum to 1, must be incorrect. To help demonstrate this, I'm going to draw a little table with 2 events and their associated probabilities. My 2 events are being in London and being in Sydney. As we established before, these are mutually exclusive events. It's impossible that they both happen at the same time. However, I don't live in London, so the probability of me being in London at 9 AM tomorrow is quite low. We could say 0.2. The probability of me being in Sydney is very low. Perhaps we could say it's 0.01. Now, these events are mutually exclusive, but if I add those 2 probabilities, that's 0.21, not 1. Now, why do people make this mistake? I think they make this mistake because they forget the difference between mutually exclusive and mutually exhaustive events. Let's now look at what I mean by mutually exhaustive events. Events are mutually exhaustive if at least one of the events must occur. Rolling a 1 or a 2 on a die are not mutually exhaustive, because I could also get a 3, a 4, a 5, or a 6. There are more outcomes that can occur than just a 1 or a 2. However, rolling a 1, 2, 3, 4, 5, or 6, those are mutually exhaustive events, because at least one of them must occur. Let's take our example of mutually exhaustive events and draw up a little probability table. Again, I'm going to list the events in the left column and the associated probabilities in the right column. So my events are rolling a 1, rolling a 2, rolling a 3, rolling a 4, rolling a 5, and rolling a 6. Assuming that the die is fair, the probability of each outcome is equal. There are 6 faces on the die, and each face is different. So the probability of each outcome is 1 over 6. If I add up all those probabilities, they sum to 6 over 6. And as I'm sure you can remember, 6 over 6 is equivalent to 1 whole. So, now that we've improved our understanding of what we mean by mutually exhaustive events, we can turn back to our original statement. It is not the case that the sum of the probabilities of mutually exclusive events sum to 1, but we can correct this. Instead, the sum of the probabilities of mutually exhaustive events sum to 1. That's it for this week's video on probabilities. If you'd like to learn a bit more about probability, check out my video on why 7 is a lucky number. As always, leaving a like really helps me out, and don't forget to subscribe to find your way back for more mathematical content. Thanks, guys.